All right, let's take a look at our learning card for the coefficient of determination. The coefficient of determination is r squared. Well, what is it? Well, we can define it like this. The coefficient of determination is the percent of change in y that can be explained by the changes in x. So when we're comparing two variables, and we've got one as our independent variable and one as our dependent variable, we obviously can see in this particular case, if we look at this scatter plot, that as hearing level increases, the loudness sensitivity will decrease. So as hearing level increases, the loudness sensitivity is decreasing. Well, is hearing level the only thing that will have an effect on the loudness sensitivity? Well, the answer to that is no. So there are other factors, there are other variables besides hearing level that have an effect on loudness sensitivity. I don't know what those are right now, but this is not the only factor that has an effect on loudness sensitivity. The other thing we want to look at is, are all the variables, or I shouldn't say variables, are all the values of loudness sensitivity the same in our data set? And the answer to that is no. You can tell that the loudness sensitivity levels are different. So there is variation among this variable. Well, part of the reason why there is variation among this variable of loudness sensitivity is hearing level. A person's hearing level has an effect on loudness sensitivity. Is hearing level the only variable that has an effect? No. But based on this scatter plot and based on R, the coefficient of determination, how much of the variation in loudness sensitivity is affected or is explained by the hearing level? Well, that's where R squared comes in. So if I were to rewrite this in a little bit different way, what I could say in a generic form is this. R squared for this scatter plot is 80% or 0.8. R squared, by the way, the coefficient of determination, is usually given in percent form. So I can say that 80% of the variation in y can be explained by the variation in x. Well, how would I write that in context? Because we always want to write in context. Well, it would look like this. Actually, that wouldn't be generic. This would be in context. And it would say this. 80% of the variation in loudness sensitivity can be explained by hearing level, or the variation in hearing level. So to say that again, 80% of the variation in loudness sensitivity can be explained by the variation in hearing level. We know that hearing level is not the only variable that has an effect on this loudness sensitivity, but how much, based on the scatter plot, how much of the variation in loudness sensitivity is explained by the variation in hearing level? 80% of it, R squared. Now, how do I use this? What is the point of this? Well, the point of R squared, the coefficient of determination, is to analyze the relationship between the x and the y variables, or the independent and dependent variables. Or you could say the explanatory variables and the response variables. And what we're looking for is we're looking to determine if other factors or other variables need to be investigated. So if we had an R squared that was really low, like 10%, then only 10% of the variation in y could be explained by the variation in x. So if our R squared was really low, we would want to look for other factors or other variables that would need to be investigated to see what effect they are having on your y variable or your response variable. So hopefully this helps you understand coefficient of determination a little bit better and how you should explain it. This part right down here in context is what you're going to say most of the time when you are looking at explaining or interpreting the coefficient of determination. So hopefully this helps you with that, and I hope you have fun in your stats class.